After 2 years of research and development, Tesla's humanoid robot is getting closer to humanity than ever. The sales figures for the initial versions could revolutionize the technology market, with a declaration of the goal to produce 1 million Optimus units by 2025. Musk plans to overcome production barriers that have the world in awe. Additionally, the advancement of AI fuels ambitious ideas about the development of Figure AI's humanoid robot, as they recently announced a list of investments in what's considered their superior technology. So, how will Elon Musk deal with these challenges? Is the technology of competitors worth Tesla's attention? Welcome to Tesla Car World. Please show your support by subscribing and ringing the bell so you won't miss out on any of our interesting videos in the future. Now, let's get started with today's content. Modeled after the human form, capable of walking on two legs and designed for manual labor, Figure's humanoid robot is currently relying on real-life human input. With millions of job vacancies in the US, Figure's humanoid robot is designed to perform tasks that people may not want to do or lack the skills for. It's envisioned to tackle more advanced tasks such as caring for the elderly or even cooking. This sounds very familiar. In 2021, Elon Musk shocked the world by revealing plans to build an AI-based humanoid robot. Initially, skepticism prevailed, fueled by the sight of a dancer disguised as a humanoid robot performing on stage. However, when the Tesla bot Bumblebee made its debut, it became evident that Elon Musk's promise held true. Returning to Figure AI's humanoid robot, the prototype they're developing bears a striking resemblance to the earlier version of the Tesla bot, with a skeletal structure and traditional rigid movements. It seems they have successfully raised a substantial $675 million in funding from OpenAI and Microsoft, alongside Amazon founder Jeff Bezos. This funding has valued Figure, the creator of the humanoid robot, at $2 billion. It appears that startup companies in the humanoid robot manufacturing are creating something akin to the first generation of the Tesla bot. An intriguing aspect of Figure AI is that none of the company's founders had an engineering background. Notably, Brett Adcock, one of the founders of Figure AI, previously founded Archer Aviation, a space aviation company manufacturing electric vertical takeoff and landing aircraft to improve urban mobility. Brett successfully built Archer into a leading global electric aviation company, raising over $1 billion in capital, taking Archer public on the New York Stock Exchange with a valuation of $2.7 billion and securing a $1.5 billion commercial deal with United Airlines. However, ultimately, they did not deliver any products to their partners, casting doubts on the notable investments made by tech companies such as OpenAI, Microsoft, and Nvidia, who seem to be repeating a noteworthy past. Furthermore, when discussing Figure AI's platform, we can't pinpoint where their AI stands in its developmental journey. Meanwhile, don't forget that Tesla is an electric vehicle manufacturer with over 5 million electric cars on the roads, all integrated with AI for real-world operational data collection. They have 25,000 NVIDIA GPUs supporting their AI systems, specifically the Dojo system, a supercomputer with 1.8 exaflop of power used for training autonomous driving systems and artificial intelligence models. Tesla invested over $500 million to build their supercomputer in Buffalo. So with a $675 million investment in Figure, it may not be sufficient to empower them to develop artificial intelligence. The deal has yet to be finalized, which means their plans might face failure. If you consider OpenAI as an AGI, I think that's correct. It's not a form of AGI in the real world, so you can't simply put it into a robot for the robot to navigate and understand the real world. This is the biggest and most challenging issue in robot manufacturing, which is why Tesla can confidently take on this risk. Robots need to integrate input from all senses in 4D, model their environment and how they fit into it, determine the goals they want to achieve, make decisions on how to move towards those goals, plan movements, and interact with humans and objects. Then they send commands to the motor control system to determine how to move the drive system to control the robot and move the limbs to interact with objects in their space, preferably with human-like movements to make it interesting to watch and not receive the uncanny valley animation effect. This sequence of motion planning must be continuously updated in a loop as the robot moves because humans and objects can move, and it has to adapt. This is difficult, really difficult, which is why we don't see many humanoid robots running around, even within the premises of other well-known tech companies with billions of dollars to develop. The progress in the field of artificial general intelligence, or AGI, combined with advancements in robotics, has posed a teasing question. How close are we to creating fully functional AGI companions embodied in human-like robots? To adequately address this interdisciplinary question, one must dissect the current landscape of both AGI and robots, examining technical, computational, and algorithmic aspects. Starting with AGI, there has been considerable development, yet it remains constrained to narrow AI or narrow artificial intelligence. These are algorithms optimized for specific tasks, such as image recognition or language translation. On the other hand, AGI aspires to possess a human-like flexibility, with the ability to learn, reason, and apply knowledge across different domains. While machine learning methods, especially deep learning, have shown significant strides, achieving true AGI that creates a machine capable of understanding, learning, and applying knowledge across diverse fields seems elusive for most companies, including Figure AI. Tesla, with its deep development roadmap and millions of vehicles collecting data for AI training, appears to be well-positioned to accomplish this ambitious task. How groundbreaking is Tesla Optimus when compared to the FigureBot? The latest revelations from Tesla provide a glimpse into the movements of Optimus within the laboratory, showcasing its flexibility steps before transitioning to a prototype FigureBot. Optimus indeed exhibits significantly longer strides than Figure, with a visible distance of over half a foot, while FigureBot has consecutive steps that don't quite capture a truly natural movement. In fact, Optimus can move at a speed of 0.6 meters per second, a remarkable improvement after Tesla announced a 30% speed enhancement for Optimus. Each time the robot's foot touches the ground, there's an impact force. Stiffness increases proportionally with the straightness of the knee, causing vibrations to transmit to the joints, making the robot's movement less natural. Humans don't face this issue as we have ligaments between bone joints that can dampen shocks upon surface contact. Tesla's almost solved this through 3 major updates. Initially, the Bumblebee version had unnatural steps, and in the first update, Tesla demonstrated addressing this issue by improving internally produced drivetrain components, eliminating the need for external component suppliers. Tesla claims a much improved balance, with significantly enhanced whole-body control, allowing it to perform a squat easily. The drivetrain converts input signals into the actual force needed to move anything from the robot's foot to the delicate movement of its fingers. In fact, the fingers' movements are so smooth that Optimus developers felt compelled to confirm that the video is not CGI and has not been accelerated, even in scenes where Optimus is moving around Tesla's lab. As for Figure AI Bot, the company's made a stunning announcement of its ability to move at 1.6 meters per second, leaving us in awe and somewhat skeptical when observing the provided daily walking footage. Such a high-speed capability seems entirely implausible. In addition, the Tesla Bot's equipped with a 2.3 kilowatt-hour battery housed in its truck, providing enough power for a full day of work on a single charge with an optimized compact design. Meanwhile, Figure AI is still in prototype stage with a frame and battery that they claim can operate for only around 5 hours, a significant consideration for humanoid robots intending to work in factories or assist humans. The low battery life may require it to be tethered to a power source when energy runs low, posing a challenge to completing tasks. Furthermore, Optimus is equipped with pressure sensors on its fingers, allowing it to sense anything it's holding, even delicate and fragile items like the thin-shelled chicken egg or easily pierced with a needle. This practical functionality sets Tesla Optimus apart. The Tesla Bot features a screen on its face displaying information, potentially serving as a substitute for verbal communication. However, akin to a Tesla car, instead of eyes, it has 8 autopilot cameras used to understand the surrounding environment. Its chest houses a full self-driving computer, providing power for all robot movements, including Wi-Fi and LTE capabilities. In contrast, Figure AI does not provide any data on the degree of freedom in arm joints, making it challenging to make a specific comparison regarding the technological breakthrough. Even in terms of pricing, the company plans to offer its robot service through subscription-based contracts. This model aims to make the robot more affordable compared to outright purchase, but specific details about the exact cost remain unknown. Essentially, the more contracts, the cheaper it becomes. Therefore, personalization for this robot technology will be affected, and if you wish to own it in the future, you'll need to buy it through a vendor contracted with Figure AI. The pricing aspect still seems uncertain. Meanwhile, Tesla Bot is expected to be priced under $20,000 when production achieves outstanding efficiency, at least for the initial model. A robot capable of performing any task, even mundane ones, is likely to come with a hefty price tag. Depending on the chosen model, I can see this fluctuating a bit, perhaps even rental options. However, this won't happen when Tesla starts selling Optimus, much like the Cybertruck or any of the company's electric vehicles when initially launched. The prices will have a high differential at the beginning and then gradually decrease. Perhaps in less than a decade, people will be able to buy a robot as a birthday gift for their parents. However, it is expected to be publicly available sooner, around 2025. Although both the Tesla bot and Figure AI bot are considered relatively affordable humanoid robots, specific details regarding cost and availability are still to be confirmed. The Tesla bot is expected to be priced under $20,000 and available from 2025 to 2027, while Figure AI bot is expected to be offered through subscription-based contracts with no specific cost or availability timeline provided. Why did OpenAI choose to invest in Figure Robot? Microsoft and OpenAI are currently in negotiations to acquire a financial stake in a startup specializing in humanoid robot manufacturing. The prospect envisions a future where robots are capable of performing dangerous tasks unsafe for humans. Bloomberg initially reported on the potential investment, which could see up to $500 million raised from various investors. This would value the startup at around $1.9 billion or higher, depending on the final amount raised. The deal is not finalized, and no one involved has confirmed its occurrence, according to reports from anonymous sources close to the plan. This investment move reflects a logical step for OpenAI, which has long been exploring ideas related to robots and large language models. Additionally, Google Bard and Gemini are demonstrating competitive performance with ChatGPT in the popular chatbot arena, ranking second on the leadership after GPT-4 Turbo, OpenAI's most advanced model. Supported by the latest update of the Gemini Pro artificial intelligence model, Bard has seen a significant improvement in performance since its release in December. This has prompted OpenAI to quickly explore new avenues, combining AI with humanoid robots. Earlier, they had intentions to acquire Figure AI, but it was unsuccessful, so the best approach might be to invest in it. Although it doesn't necessarily mean there will be robots with ChatGPT in their brains, the concept of using large language models like GPT-4 to power ChatGPT as a control mechanism for robots is not entirely new. Altman also revealed that the company once had a robotics division, but they prefer to focus on intelligence first. They believe mastering intelligence and perception is a priority before adapting to physical forms. Once robots gain the ability to think for themselves, and if hardware improves enough to harness this intellectual capability, they could quickly transform the job market, especially in manual labor fields. The initial prediction for AI was that it would take on those manual labor tasks first, automating repetitive tasks and making humans feel estranged. In reality, things seem to be unfolding differently than what people first thought 10 years ago, when everyone believed it'd just be blue-collar jobs first, then white-collar jobs, and it would never impact creative roles. However, recently, OpenAI introduced Sora, capable of replacing the creative roles of artists and filmmakers. This scenario paralyzed what happened with Elon Musk since he founded OpenAI with a nonprofit declaration. Due to disagreements in the mission, Musk decided to leave OpenAI, and Sam Altman seems to have transformed it into a for-profit company. This has led to Elon Musk's lawsuit against OpenAI for abandoning the mission of benefiting humanity. Musk alleges that OpenAI's collaboration with Microsoft has turned the organization into a de facto subsidiary of Microsoft, focusing on maximizing profits. The lawsuit aims to compel OpenAI to adhere to the founding agreement and return to the mission of developing AGI for the benefit of humanity, rather than serving the interest of Altman, Brockman, and Microsoft. Musk criticized the potential risks that AI progress could pose to society even before co-founding OpenAI, calling for protective measures to prevent such systems from being used to replace humans. Furthermore, it appears that investors perceive Tesla as a threat to their developments in the technology sector. Hence, they felt the need to invest in similar Figure AI or any humanoid robot technology company to disrupt Tesla. Similar to OpenAI's future plans to implement AI into machines and create their humanoid robot. Each company has its own narrative. For most companies, designing their own chip is an extremely challenging task. However, Tesla, one of the world's largest developers of autonomous vehicle technology, deems it a worthwhile investment. At the Hot Chips conference, Elon Musk shared the secrets behind the advanced AI chip design of the company, stating that only 2 chips are intelligent enough to enable fully autonomous driving for the upcoming Tesla model. Chip designers demonstrated a significant optimization level in Tesla's custom AI chips, leading to a substantial performance increase, 21 times more than previous NVIDIA chips. Moreover, Tesla's chip production costs are 20% lower than NVIDIA's. Each of Tesla's AI chips run at a speed of 2 gigahertz and perform at 36 trillion operations per second. NVIDIA continues to be the chip supplier for Tesla, and Musk previously mentioned that Tesla was using too many of NVIDIA's chips to power its self-driving vehicle training systems, causing the chip manufacturer to struggle to meet their demand. This prompted Tesla to build its own supercomputer, and NVIDIA needs additional customers to consume their technology. What will have a greater impact on humanity in the future? The emergence of full self-driving in Tesla bot could have significant financial and production implications for Tesla. The widespread deployment of FSD and its broad application would lead to a substantial increase in revenue, with Tesla recognizing delayed revenue for its autonomous driving features. The long-term financial impact would become more pronounced as the efficiency gained from FSD results in higher production volumes and increased profitability. Similarly, the implementation and utilization of Tesla bot across various industries would contribute to Tesla's development. The revenue potential from selling or leasing Tesla bots could be substantial, with each unit serving as an income-generating asset for the company. Scaling up the production of Tesla bot, combined with the integration of automation in Tesla's factories, would further enhance manufacturing capabilities and drive profits. With the latest version of Figure AI, we can observe a clear copycat version, so it seems unlikely to be a formidable competitor capable of surpassing Optimus unless equipped with Tesla's FSD or possessing millions of pre-existing training units. Finally, what new innovations do you hope for Optimus in 2024? One of the main concerns surrounding sodium-ion batteries is their energy density, a key parameter in determining the driving range of electric vehicles. Compared to established lithium-ion batteries, sodium-ion batteries tend to have a lower energy density. Specifically, popular lithium-ion batteries have an energy density of 100 to 250 watt-hours per kilogram. But the best sodium-ion batteries today only reach 160 watt-hours per kilogram. And sodium-ion technology is not as well established as lithium-ion. However, sodium-ion is still being revived to become the best choice in case manufacturers face lithium battery depletion. Now, the best question would be, will Tesla really put sodium-ion batteries in their electric cars? And how is sodium-ion battery reviving? To make it clear that sodium-ion batteries are making a comeback, let's look back to previous times when this battery technology was developed in parallel with lithium-ion batteries. In essence, the development of sodium-ion batteries took place in the early 70s and 80s. However, by the 1990s, lithium-ion batteries had shown more commercial promise, causing interest in sodium-ion batteries is decreasing. However, around 2010, due to large supply requirements, the cost of lithium raw materials skyrocketed, nearly doubling compared to 2009. Specifically, the price of lithium carbonate, the most common form of raw lithium that manufacturers use for electric vehicle batteries, increased from $4,000 a ton to $7,500 a ton that year. It can be seen that this is where sodium-ion batteries are sought after when concerns about raw material prices continue to increase sharply in 2011 and the future. Sodium-ion batteries operate similarly to lithium-ion batteries, with both sodium and lithium components relying on the intercalation of ions between host structures. Additionally, the sodium-based battery structure is almost identical to that of common lithium-ion batteries on the market. However, sodium-ion batteries have some fundamental differences with lithium-ion regarding the electrode material. Lithium-ion batteries use lithium ions, Li, as the charge carrier. They typically use lithium-based compounds for the cathode and carbon-based materials for the anode. Meanwhile, sodium-ion batteries use sodium ions as the charge carrier. These types of batteries typically use sodium-based compounds for the cathode material, and the anode will often be hard carbon. During charging, sodium ions move from the cathode to the anode while electrons move through the external circuit. During discharge, the reverse process occurs. These differences bring both advantages and disadvantages. In our opinion, this is exactly what makes sodium-ion batteries so potential but not yet widely applied. But of course, they are the factors that make sodium-ion batteries gradually gain a foothold. Let's talk about the advantages first. As for sodium's biggest advantage in replacing lithium, the abundance and wide distribution of this element will certainly meet the growing demand for electric vehicle batteries and energy storage. Sodium's abundance is up to 1,000 times greater than lithium, helping to create large reserves of raw materials, ensuring a stable supply and reasonable market value. Not only is it an abundant resource, sodium is also more evenly distributed globally than lithium, minimizing dependence on countries with resource advantages, as many times the U.S. lithium-ion market is facing supplies from China and other countries. Many electric vehicles are ineligible for the $7,500 federal tax credit simply because the lithium in the batteries comes from China, including Tesla. An abundance of lithium would be a way to help reduce supply risks while promoting stability in the North American battery industry without worrying about limiting rebate tariffs. Known to be the sixth element in the Earth's crust, accounting for 2.3%, sodium not only stands out for its abundance but also for its regularity and prevalence. This means that the cost of extracting and manufacturing batteries using sodium will decrease, creating a significant economic benefit. In terms of raw materials, lithium costs about $570,000 a ton, while sodium is only 3,190 times cheaper. Thanks to cheap raw material costs, sodium batteries are also 7 times cheaper than Tesla's lithium batteries by 2022. Specifically, the Tesla 4680 battery costs about $101 per kilowatt hour, but sodium batteries are only $15.15 per kilowatt hour. The cheaper price could be an important deciding factor in the decision to switch to sodium batteries in various applications. In addition, the ability to extract sodium from seawater also opens up an unlimited potential source of raw materials, helping to reduce pressure on the environment and natural resources. This makes sodium an environmentally friendly choice, while meeting the increasing demands for sustainability in battery production and use. In addition to abundant reserves and environmentally friendly supplies, the safety and stability of sodium-ion batteries are also factors that allow it to become the second choice after lithium. According to Dr. Huang, deputy head of research at Tesla's partner company, CATL, said that sodium batteries are more difficult to catch fire than current lithium batteries, which is a plus point in terms of safety. In addition, the performance of this type of battery at low temperatures is also better than lithium batteries, he added. Sodium-ion batteries still achieve more than 90% at minus 20 degrees Celsius and 70% performance at minus 40 degrees Celsius. The charging speed of sodium batteries is also very fast when it can charge from 0 to 80% in just 15 minutes. It's an ideal temperature for sodium-ion batteries. It'll range from minus 20 to 60 degrees, but some knowledge indicates that sodium-ion batteries have an even wider temperature range from minus 70 degrees temperature to 100 degrees Celsius. The article says that even at minus 70 degrees Celsius, this battery still provides 70.19% of its capacity at room temperature. Furthermore, thanks to the high boiling point of the electrolyte, this type of battery also operates well at high temperatures up to 100 degrees Celsius. Sodium-ion batteries can also be discharged to 0 volts during transportation, avoiding the risk of thermal runaway, something that's difficult for lithium-ion batteries. The fact is that lithium-ion batteries usually operate optimally at 15 to 35 degrees Celsius, and when the temperature drops below 0 degrees Celsius, battery capacity will decrease rapidly. For example, at minus 20 Celsius, the battery capacity is only 50% of normal. Reaching too high a temperature can cause oxidation of the cathode electrolyte and the chemical composition of the lithium battery, leading to loss of battery capacity and accelerating the aging process. Another truth is that lithium-ion batteries easily explode when exposed to high temperatures, which is one of the reasons why many people still have a negative view of electric vehicles. Fires involving lithium-ion batteries are known to be very violent. The fires often spread very quickly and are extremely difficult to extinguish. Lithium-ion battery fires are also capable of generating large amounts of toxic smoke that's hazardous to human health. In terms of reuse, both types of batteries are recyclable, but lithium-ion batteries stand out for being easier to recycle and more environmentally friendly. The reason is that sodium's simple and benign chemical structure helps reduce the environmental burden and increase the ability to reuse resources. In particular, it contains less toxic ingredients such as cobalt, making the production and recycling process safer. This could be an important step in building a clean and sustainable energy industry of the future. So, what are the disadvantages of sodium-ion batteries and how are they trying to overcome this barrier? Besides the potential to replace lithium, sodium batteries still have many limitations that need to be improved if they really want to be applied to the electric vehicle field. The biggest disadvantage is that sodium-ion batteries have a lower energy density than lithium-ion batteries. As we suggested above that lithium has an energy density of 100 to 250 watt-hours per kilogram, but the best sodium-ion batteries today only reach 160 watt-hours per kilogram. This is because sodium is significantly heavier and larger than lithium, as well as sodium having a higher reducing power than lithium. From this, it follows that if an electric vehicle uses a sodium battery of the same size as a standard lithium-ion battery, it'll not be able to travel far on a single charge. Not stopping there, sodium-ion batteries also behind in volumetric energy density, up to 365 watt-hours per liter, compared to lithium-ion battery about 670 watt-hours per liter. It's quite sad that the price is cheap, but sodium batteries can only store about 2/3 of the energy compared to lithium batteries of the same size. So the battery will run out faster and have to be charged more often. Lithium-ion batteries are also slightly more efficient when it comes to using the energy stored in the battery, as they use 90% of the stored energy, compared to sodium ions 80 to 85%. Lithium-ion batteries are also more efficient when charging. They charge faster and can withstand more charging cycles. Sodium-ion electrodes suffer structural deterioration during repeated discharge cycles, typically about 3,000 cycles, while lithium-ion chemistries used for off-highway applications can withstand up to 10,000 charging cycles, depending on the cell chemistry chosen. In some ways, this may reduce the cost advantage of sodium-ion batteries in the long run, as they'll need to be replaced more frequently than lithium-ion batteries. But according to many experts, continuous improvements in energy density and improved cycle rates are making sodium batteries more durable, making them more competitive. Of course, it's still in the developmental stage, and there are many more promising mutations. In short, the reason why sodium-ion still can't compete with lithium-ion batteries is due to lithium's privileged position in the chemical hierarchy. Even though both are metals and both belong to Group 1 of the periodic table, lithium is at the 3rd position, while sodium is poorly stuck at the 11th position, which is lower than lithium in activity. For a metal, you simply can't get better than lithium in terms of the amount of ionization potential per energy it naturally provides for its atomic size and simplicity. Therefore, it is fundamentally difficult for sodium-ion batteries to surpass lithium-ion batteries in terms of energy density or operating voltage. They may be cheaper for the same amount of watt-hours, but they'll still be larger and heavier. When it comes to applications like cell phones and laptops and even cars, being cheaper won't help if they can't deliver, especially power in the same amount of space or within volume limits. So, will Tesla put sodium-ion batteries in future electric cars? The answer is yes. It's even possible to become a popular battery type that makes a mark for Tesla cars if Elon Musk is really serious and researches carefully with sodium-ion batteries. Currently, Tesla has not announced official information about integrating sodium-ion batteries into its vehicle models. However, there are signs that they may consider using this battery technology in the future. One possibility is that when the input costs for lithium batteries become too expensive, Tesla may decide to switch back up to sodium-ion batteries. In this scenario, the use of sodium-ion batteries could be focused on lower-priced vehicles, such as the robotaxi or shorter-range models that Elon Musk will develop in the future as a feasible situation. This helps Tesla stay competitive in this market segment and also reduces pressure on battery costs. Lithium prices will be extremely fierce in the coming years. With the ability to operate down to minus 70 degrees Celsius, a more credible theory is that Tesla could offer sodium-ion battery packs for electric vehicles as a lithium alternative for customers in colder climates. However, this decision will depend on a number of factors, including whether the customer agrees or not. Not only Tesla, but major electric vehicle manufacturers have also considered and put in sodium-ion batteries into research factories. Of course, for application on electric vehicles, there are criteria that need to be met. The first is to have sufficient power density to achieve good driving range. If that passes, then they'll start looking at other things like battery life, manufacturing costs, charging speed capabilities. At the present time, it's unfortunate for sodium-ion that it cannot overcome the first two. That's not to say that modified versions of its chemistry won't one day get there. It's not currently optimal with current lithium-ion battery technology, which is also slowly improving over time. The truth is that it takes a long time to transform technology. If sodium-ion batteries reach their full potential, it's likely that Tesla will switch to using it. In the past, Tesla has switched to LFP for some of its vehicles, which, while still lithium, significantly eliminates less sustainable raw materials. Some companies in China, such as JAC, have launched electric vehicles powered by sodium-ion batteries with a capacity of 25 kilowatt-hours and an energy density of 120 kilowatt-hours per kilogram. With 3C to 4C charging, the electric hatchback can recharge from 10 to 80% in 20 minutes. BYD is also expected to soon launch electric cars powered by their sodium-ion battery on the market. Once the sodium-ion battery is complete and meets the criteria, Tesla can cooperate with professional battery manufacturers such as CATL, who are pioneering the development of sodium-ion battery technology. This partnership gives Tesla quick access to the new world of sodium-ion batteries, and at the same time minimizes risks due to support from experienced partners. This could greatly benefit both Tesla and the auto industry, driving innovation and progress in the field of electric batteries. Chinese battery giant CATL could begin mass production of sodium-ion batteries as soon as next year, and several startups are also working to increase sodium-ion battery production capacity. UK-based Veradian has been focusing on sodium batteries since 2011. Hyna battery technology in China, Tiamat in France, Altris AB in Sweden, and Natron Energy in the US are all commercializing sodium-ion technology. In the short term, sodium-ion batteries could be used for applications requiring lower energy density. Longer-life batteries such as stationary storage, potentially easing some of the limitations on supplies raw materials for the lithium-ion batteries needed for electric vehicles. Demand for critical battery raw materials is expected to grow exponentially, not only in North America but also EU countries transition to renewable energy systems in electric vehicles. The green transition will also require more local production of batteries and other new fossil-free technologies, and a steady supply of raw materials to meet demand. At the same time, such production has a huge risk of supply disruption due to the limited number of raw material sources. Although lithium-ion batteries are becoming the dominant technology in the world, they're better for the climate than fossil-based technology, especially when it comes to transportation. But lithium poses a bottleneck. We can't produce lithium-based batteries at the rate we want to produce electric cars, and deposits risk running out in the long run. Additionally, key battery materials such as lithium and cobalt are largely mined in only a few parts of the world, putting supplies at risk. The comeback of sodium-ion batteries is a promising story, mainly because the fierce competition in the electric vehicle market has presented a particular challenge to lithium-ion batteries. Although lithium-ion batteries have become a popular choice in many electronics and electric vehicle applications, the scarcity of lithium supplies is increasing costs and putting great pressure on the industry. In this context, sodium-ion batteries have emerged as a potential option, especially with the abundance of sodium raw materials, helping to ease supply pressures and reduce production costs. This creates a strong motivation to develop and research sodium-ion batteries, especially when they have outstanding advantages in cost and safety compared to lithium competitors. Although current sodium-ion batteries only have one main drawback, which is lower energy density than lithium-ion batteries, but with investment and research from experts like Jeff Don, it's no longer a problem. It's too far-fetched to talk about a new battery revolution. Researchers are aiming to solve this problem to take sodium-ion batteries to the next level, delivering remarkable stability and performance, creating momentum for their popularity and resurgence of this battery in the near future. So, how do you feel about sodium-ion batteries in the context of lithium-ion batteries being prioritized at present, and what do you think will make manufacturers pay attention to sodium-ion batteries? We appreciate your contributions. We hope you'll have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Tesla Car World family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thanks so much for watching, and we'll see you soon. Until then, stay safe and have fun.